Welcome back, everyone. We're going to work on examples of solving systems of equations using graphing. And once we have those two equations graphed, we'll find where they intersect and then give the coordinate point for that. In example 1, we have 2x minus y equals -4 and x minus y equals -1. And we need to graph both of those equations. The first one, we need to identify the x-intercept and y-intercept. And for the second one, we also will need to find the x-intercept and y-intercept. So the process is the same every time. We're going to set the y equal to 0 to find the x-intercept. And when we do that for the first equation, we will have 2x equals -4. And then if we solve for x, remember 2 is multiplied to the x, so the opposite of multiplying is dividing, and we get x is equal to -2. So the coordinate point for the x-intercept is at -2, 0. For the y-intercept, we'll let x equal 0. And when we substitute x equals 0 into our equation, we get -y is equal to -4. When we divide by -1 through, we'll get y equals 4, and our coordinate point becomes 0, 4. We can plot these points on our graph and then connect the dots. -2, 0 is our first coordinate point for the x-intercept, and 0, 4, and I'm going to have to imagine where that point is, sort of, is up here along the y-axis. Now I'm going to do the same thing for the second equation. I'm going to connect the dots though, because that's important. Notice that when I'm going through this pattern, I have a rise of -1, 2, 3, 4, and a run of 2. So that means that I could reduce it to a rise of -2 and a run of 1. So I'm just making sure that when I line up all these slopes, they're all hitting along that same pattern. Even if you're not plotting the points, you want to make sure that you're graphing that and keeping track of that as you go. Now let's go ahead and do the x and y intercepts for the second equation. When y equals 0, we have x is equal to -1, and that would give us a coordinate point of -1, 0. For our second part, the y-intercept, we have x equals 0. When x equals 0, we have -y equals -1. And so I can divide both sides by -1 and get y equals 1. So the coordinate point for the y-intercept is 0, 1. So I'm going to graph that, -1, 0, and 0, 1. So we have an intersection at the point -3, -2, or 3 to the left, down 2. So that is the solution set. We could also say x equals -3, y equals -2, and that's the answer. Let's go ahead and solve the systems of equations in example 2. We have 2x minus 2y equals -4 and x minus y equals -1. I am going to once again go through the process of graphing both equations. When x equals 0, that will be my y-intercept. And so I can substitute that in. That would be 2 times 0 minus 2 times y equals -4. And so y is equal to 2. So my first coordinate point, the y-intercept, is at 0, 2. If I now find the x-intercept, that will be when y equals 0. So substituting that in, I'll have 2x is equal to -4, and dividing -4 by 2 on both sides will give me x is equal to -2. So the coordinate point for the x-intercept is -2, 0. 0 up 2, to the left 2, down 0. And now I can connect the dots. Now let's go ahead and try the second graph. For my y-intercept, I'll have x equals 0. And substituting x equals 0 in, I'll have -y equals -1, which implies that y equals 1. So my coordinate point will be 0, 1. Now for the x-intercept, y equals 0. And substituting y equals 0 in, I'll have x is equal to -1. So my coordinate point is -1, 0. So plotting those two intercepts, 0, 1, and also -1, 0. And now connecting the dots, you can see that these are parallel lines. So if you wanted to see what kind of solution you'd have, this solution does not exist. You might be wondering, could I have noticed this without doing all this work over here? And the answer is absolutely. The way you tell is if you have a common factor that you can divide out of everything, because if there is, then it will most likely come out to look exactly like the other equation. So let's see what happens. If we divide everything by 2, we'll get x minus y equals -2. Notice that that looks very similar to what we had with the other equation, x minus y equals -1. This has to imply something, and I hope you can make that jump, which is that the value on the right-hand side will show you where the graph might be intersecting the y-axis, but x minus y implies that the slope is the same. And you could prove that to yourself with some work, but for now it's just important to recognize that the slopes ended up being the same. Therefore, since the y-intercepts are different, they will never touch each other.